Okay, so in this tutorial I'm going to go over how to kind of model the types of forms that you would have generated in making your fabric form and concrete casting models. So I'm going to start by opening Rhino. First I'm going to change my units. Type in units, go to, make sure you're in inches. Okay. And next what I want to do is create some points in Rhino. So I'm going to use the command point, and I will, for my first point, I'm just going to locate it at 0, 0, enter to place that first point at the origin. Then I can copy it, so I'll copy it. And then what you want to do is move the point according to the increments that defined the size of your fabric form when you built the fabric form framework. So I just made mine 12 by 12, but use whatever units or dimensions you used in your fabrication. And what we're going to do is actually use a software called Kangaroo Physics. So if you go to your browser and search food for Rhino, what you want to search for is Kangaroo. And you'll need to log in first in order to be able to download the file, or create a login if you don't have one already. You want to download the latest version of the software, which is this one, 2.42. Just click download. You can see I've already downloaded it. And then in your wherever it gets downloaded, if you go ahead and open that up and open the PDF inside of there, and scroll down a bit, and you will find on page 2, you'll find a set of instructions for how to install Kangaroo. So it'll give you all the information you need. First, you need to unblock the zip file, so you could do that by just right-clicking on that download, go to Properties, and check Unblock, click OK. And then it'll walk you through like where to find the Grasshopper components folder. So you need to copy those two files, kangaroo.gha, kangaroosolver.dll, these two files that are in that folder, to the Grasshopper components folder, which you can find by opening up Grasshopper, go to File, Special Folders, Components folder. And so if you just copy those unblocked files into this folder, then you'll have to restart Rhino and Grasshopper in order for it to load. And then you should find that the next time you open Grasshopper, you'll have Kangaroo 2 up in the top. Okay, so beginning from these points, I'm going to go ahead and show you how to model the simplest type of form, which is the hyperbolic paraboloid surface. So I'm going to make again, in Grasshopper, I'll go to Parameters, Geometry, and I'm going to choose the component for point. Now, point is going to allow us to reference any type of geometry that's in Grasshopper, or I'm sorry, in Rhino, inside of Grasshopper. So I'll click on this point, right-click, and choose Set One Point. So I'll click on one of my points. I'm going to go ahead and keep them all separate because that'll be just easier to kind of manipulate later on. So I'm going to go ahead and select this component and make a copy, paste, and I'll make 2 more copies. I can align them real quick. Okay, and then I want to set each of the points of my square or of whatever my shape is. Okay, great. And now, in order to make this a surface, and it's important that we do that in Grasshopper, we're going to go down to the Surface tab, Freeform, and choose 4-point surface. And you'll see that on the surface 4-point component, there are 4 inputs. That stands for the 4 corners of your surface. If I just go ahead and start plugging these points into that surface, you can see we've created a square that spans between those 4 points. What I want, so now I have my geometry established. What I need to do in order for Grasshopper to be able to run Kangaroo is I need to actually turn this surface into a mesh. So Kangaroo is a physics simulation engine, and it works by simulating on meshes, essentially like a collection of particles. So what I want to do is go to the Mesh tab. I want to go to Primitive, and I want to go down to where it says Mesh. Excuse me. Sorry, go to Utility and go to Mesh BREP. This will allow me to, if I plug my surface into that, into the B input, so if I hover over B, it'll say BREP geometry. Usually that means polysurface. In this case, we can just plug our surface directly into that and it'll still work. And then I would go ahead and unpreview my surface so that I'm not looking at two, kind of instances of the same geometry. So I'll highlight my surface component, right click, and uncheck preview. Okay, and then the last thing that we want to do, just to kind of construct our mesh, is to give it some settings. So again, I think you can go to Utility, and right under Mesh BREP, go to Settings, the one where it says Custom, and you can see the settings output. Just plug that directly into the S input on your BREP mesh. And what we want to do is set a number in here, in the minimum and maximum value, to define how many subdivisions our mesh has. So before I do that, I'm going to go over to the Analysis tab under the Mesh tab and get this component in Mesh Edges. So by default, Grasshopper will not display mesh edges in the Rhino viewport. So what I want to do is I'll go ahead and plug that mesh into my mesh edges so I can see what the actual subdivisions are. And we'll also use that component later. And then over here on minimum and maximum, that's where we want to set the number of subdivisions each of our surfaces has. So I will go ahead and make a number slider. So the best way, you can go to Parameters, Input, and get a number slider. If you want to automatically set it to a certain number, just go ahead and double click on the canvas and type the number that you want into that dialog, and it will automatically make a slider that has that number. So I'm going to plug that into minimum and maximum. That means that our number of subdivisions can only be this, 16. And you can see as I slide it up and down, it'll change the number of subdivisions our mesh has. So I'm going to keep it pretty low for now. Again, you don't want to crush your computer by having a super high number of subdivisions. So I'll keep it on 24 for right now. One more thing we want to grab before we start to set up the physics simulation is to go back to Mesh, go to Analysis, and choose the component Deconstruct Mesh. So I'll place that right under there. I'm also going to plug in that mesh to the deconstruct. And if we look at the outputs, the first one is the mesh vertices. And what that means is those are the actual points at the intersection of each subdivision of the mesh. And we're also going to need those points in order to do our simulation. So I think we're set up now. We can go ahead and go to Kangaroo 2 and start to create our physics simulation. The first component I'm going to grab is under Main, and I'm going to grab this one called the Bouncy Solver. So this is the actual component that will run the simulation. And a couple things I want to set up first for this component is the reset button and the on button. So like with the Ladybug tutorial, I'm going to use a Boolean toggle. So I'll double click, search Boolean toggle. So I'm going to grab that component and I'll plug it into on. That's the easy way to turn this thing on and off so it's not running all the time while we're making adjustments. And the other one I want is a button for reset. And instead of using a Boolean toggle, I'm going to use just a button. So double click and search for button. And so basically that means that each time I click that, it'll restart the solver. So if I make any changes, I can just click my button and it will update with those changes. Okay, so what we're trying to do essentially is to simulate the effects of a piece of fabric. The first step is to give that geometry some physical properties so that we can see how it is modified when we sort of simulate it. So I want to go to Goals Line under Kangaroo 2, and I'm going to choose this one for line length. So this is where the mesh edges will come in. If I go to Parameters and go to Geometry and choose the component curve, where is it? Curve. So if I go ahead and plug in E1 into the curve, and I select it so you can see what's highlighted in Rhino, you can tell that that's the outside edges of our mesh. And if I were to plug in E2 and highlight it, you can tell that's the inside edges of our mesh. For this type of simulation, we don't really care. We just need all the edges. So I'm going to go ahead and hold Shift. You can see that little green arrow appear, and plug that into my curve. So I want E1 and E2 plugged into my curve component. And so that will collect into one component all the edges of my mesh. And then I can go ahead and plug that into the line input on my length component. The next thing that I want to do is set up some of these properties. For the length of my line, I'm actually going to get a component called curve length. So if I go to Curve, Analysis, there's one called Length. So it's a really simple component. If I plug my curves into that guy, and we look at the output, you can see what it's giving me is a list of numbers, and those numbers represent the length of each segment of the set of curves. So I can go ahead and plug those directly into length, or what I can do is I'll go over to Math, I'll go to Operators, and I'll go to Multiplication. Because what this component does is it takes a set of lines, and it takes a set of lengths, and it tries to make those lines reach that length. And all that means for us is if we plug our length into multiply, and then we'll go to Parameters and get a number slider. So we can multiply the length of our lines by a number between 0 and 1, which should return a smaller number than the actual length, right? And as the solver is trying to reach a surface that has shorter lines, what that's going to do for us is simulate the effect of a stretchy piece of fabric. So I'll show you how that works in a second. The other thing I want to set here, just so we can kind of tune the outcome of our simulation, is the strength factor. So for this, I also want a slider, a number slider. I'll just double click, and I'm going to type in 100. So I'll set this to a lower number just for now, and I'll plug that into strength. Okay, so now we have our we have one property, which is the stretchiness of our fabric established. And another thing we need to do for Kangaroo to work is to give it what are called anchor points. So if I go back to Kangaroo 2 and go under Goals Point and select this component for anchor, what this guy will do is take certain points that we give it. So I'm going to go back to the beginning of our, or the start of our definition, and I want to plug all my 4 corner points into that anchor point component. So I'm going to go ahead and drag this over. Again, I'm going to hold Shift on the keyboard to plug in multiple, just holding Shift the whole time. Okay, so now we have all 4 points set up in this anchor component, and what this will do is it will make those 4 corner points of the surface not move. So it's more or less like we've pinned the fabric at 4 corner points, and we're kind of stretching it. So we need to tell Kangaroo which points we want not to move. I'll go ahead and plug that into goal objects. And then the last thing we want to do is plug in a component called show. It's under main. It just looks like a little light bulb. And I'm going to plug my mesh into that guy. So I'll just drag the output from my mesh component into the show. And that's just going to make sure that we get a mesh output when the simulation is done running. So if I go ahead and plug the rest of these in to my goal objects, so again, I'm holding shift. Okay. And before I do anything else, what I also want to do is actually unpreview a bunch of stuff. Because when this thing runs, it's going to show us a new mesh that has the kind of physical properties applied. So what I would do is I would go over here to my mesh component. I'm also going to go to my curves. And I'll turn off my points as well. Right click and click preview off. So you can do one by one or all at once. Okay, and I think we're ready to go. So if I go ahead and uncheck false, that means that the solver is now running. And you can see what happened pretty quickly is the surface turned into something that looks like a stretched piece of fabric. So if I go over to where my length input was, right, because the fabric is trying to reach a length that's much shorter than what the individual lengths are, we can see we're reproducing the effects of a stretchy piece of fabric by changing that value. That's the first set of properties we're going to apply. Now, if we wanted to simulate, I'm going to go ahead and toggle this to false again. You can see it's still showing us the result. If I were to click the button, that resets the simulation. So now we're back to 0. We're back to before we started. One more thing I can do with this simple setup would be to actually apply, would be to move the anchor points so that I can simulate something like what the hyperbolic paraboloid would give us. So what I need to do is actually reset the position of a couple of these points in Grasshopper. So I could go over to transform. I could go to Euclidean and get a move component. And what this guy will do is allow us to reposition a couple of these points that we choose. So I'm going to go ahead and plug this one into my move component. You can see that it has a default vector, so it's moving it, to a random position right now. So the move component needs a geometry to move, and it needs what's called a vector, which means a direction and a length. If we go over to the vector component, the vector tab, click on vector, we're going to grab something called a unit z. So this is a standard z vector. If I plug that into the t, you can see it's moving that point up in the z dimension by 1 increment, or by 1 inch in this case. Now we can also set the distance by applying a number slider to the input of our z vector. If I double click on the canvas, I'm going to type in 10.0. And I'm going to plug that into the f input on my z vector. Okay. Now if I look at my move component, the position of that point will change depending on what my number slider is set to. So I'm going to leave it at 0 for right now. And I'm going to go ahead and copy this move component. Control C, Control V. You can also copy stuff by dragging it and tapping Alt on the keyboard. Either way works. So I'm going to get 2 opposing corners of my surface. So I'm going to get this one as well. And I don't want to copy the z vector or the number slider because I want to kind of move both these points up by the same increment. So now I'm moving my points, but you can see if I look at my surface that my surface is not changing, just my points are. So what I actually need to do is replace the input to this surface for those points with my moved point. Now, first what I can do is if I want to unplug something in Grasshopper, I'll just drag over from the component that it's plugged into and hold Control on the keyboard. You'll see a little red arrow appear by your cursor. And so that point just became unplugged, that one became unplugged. And then I can replace it with my moved point. Okay, and now when I go ahead and move those points, you can see that it's adjusting the geometry of my surface. Now it's also reproducing this crazy effect. I'll just hit reset on my solver. That's just a kind of side effect of having this thing previewed, so I'll unpreview it for now. Okay, but also we need to make sure that the moved points are plugged into our anchor points as well, our anchor component. So I can go ahead and hit Control on the keyboard to unplug those two that I have plugged into my moves. And then I'll hold Shift, or I'm sorry, not from there, I'll hold Shift and plug them in from my moved point. Okay, so now I've replaced all the points for my surface and for my anchor points with those two new moved points. Now I'm going to preview the bouncy solver again, so I'll select it, right click and go to preview, on. Okay, I'm also going to unpreview my surface. Preview off, okay. And then from here, if I toggle the solver back on, you can see our surface tension is still working. And if I go back over to where my number slider is, and I drag that guy over, you can see that it's starting to produce something like what the hyperbolic paraboloid surface would be. Now, I'm not entirely sure why it's giving us this kind of weird result. One thing we can do is we can select to show just the output that we want from our solver. So if I hover over the O or the objects, or I'm sorry, outputs, output on our bouncy solver, you can see there's all kinds of information in there. So all our lines are in there, our meshes, our anchor points. Now we just want to select out the mesh. So I will go to Parameters, Geometry, and choose a component, a mesh component. Now if I plug the output into that guy and then unpreview the bouncy solver, you can see it's just showing, the reason that it's red is it says data conversion failed from line to mesh. So it's only showing items in that list that are meshes. And that's why it's giving us a little error bubble. So we can just ignore that. And I can also go back here and copy my mesh edges component and plug my mesh into that guy, preview it. Okay, and so that's showing just the result of our simulation. And if I were to if I were to move the slider, you can see that it's also showing us what would happen if we stretched or if we changed the kind of tensile properties of that surface. Okay, so we leave it at 0, hit reset. It would give us like, you know, what that surface would be with just a straight edge constraining the outside of the fabric. And if we start to move the slider for our edge lengths, we can see what it looks like if we're constraining that surface to a set of points. Okay, the other thing that I want to do now, so I'm going to go back over here and double click my toggle. So now my simulation is off. I'll hit my button one more time. Okay, I can move my surface back down. The next type of surface, so that's basically like that type of simulation will allow you to create a geometry that has what's called, or is a minimal surface. So if you were to refer to your assignment sheet, it'll give you a definition of what a minimal surface is. But basically it's the smallest amount, or it's the surface with the least surface area constrained to a set of points or edges. So that simulation allows us to reproduce the effects of a minimal surface, like what you have with the hyperbolic paraboloid. But we're going to add one more property to our surface in order to reproduce the effects of a catenary surface. Now if we go back to Kangaroo 2 and click on Goals Point, we will select this one called load. Now, this input requires a set of points. Now, this is where our deconstruct mesh comes in. So that if we look at the outputs, we can see the V output is producing a point, vertices. And I will go ahead and plug that into the P on my load. And if I hover over the FV, you can see that that's looking for a vector. So what this thing is essentially doing is allowing us to simulate the effects of weight or of gravity. So once again, if I wanted to apply like a gravity force, what I could do is I could plug in a Z vector. So I can go to vector, vector, unit Z. Now you can see if we hover over the output there, what we're getting is a positive Z vector. And gravity obviously pulls downward, right? So what we need to do is actually invert this vector. We can do that by just double-clicking on the canvas and type in negative. Now if we plug our vector into that guy and then plug the output into the FV, that will apply a negative downward force on every point in our surface. So I'm going to go ahead and add this output to my goal objects. I'll hold Shift. Okay, so I don't unplug everything else. Now I will double click on false. So you can see what happened is it pulled our surface way, way, way down, way further than we wanted it to. So I'm going to untoggle true, reset it. And what's happening here is our force is way too strong, and our surface is not strong enough to resist that force. So we can alter two inputs here in order to adjust the result of our simulation. So one of them is the strength of our Z vector. So I could get a number slider. I'm going to go 1.00. As you know, the default is 0, so I could turn that down. So I will toggle this back on. Okay, and you can see now that we've produced something that's a lot more subtle in terms of its curvature. And if we were to go back to our force vector, you can see that the higher that value goes, the more our fabric kind of gets slumped, and the lower, the less. And likewise, if we turn the forces way up, but also turn up the strength of our length component, so turn that value up, you can see that that's going to also reduce the effects of the kind of slumping. What that's useful for is kind of reproducing, you know, basically the effects that you got from your physical prototype when you did this process. So you may have had a geometry that was much more kind of steeply slumped or steeply curved. Now, if we want to make our surface have a kind of finer resolution, we can still go back to our custom mesh settings, and if we turn the subdivisions up, you can see it's subdividing our surface into more and more little squares. Now I should point out at this point that anytime you make a change like that, like a change to the geometry, it will cause the solver to create an error. All you gotta do is click reset, and then it should kind of fix itself. But you can see that because I added more subdivisions, my object is actually not only smoother, but it's also slumped a lot further downward, right? And the reason for that is because if we have more points in our surface, so if we have more points because we have more subdivisions, then we also basically have a greater cumulative load applied to our surface, because this load is being applied to every single point. So just to point out, you know, like you'll have to kind of balance the number of subdivisions with the you know, the strength and gravity forces that you've applied. And once again, your goal is basically just to reproduce kind of the effect or the kind of slumped quality of whatever you did in your physical prototype. Now there's one last example I want to show you. So I'm going to toggle the solver to off, reset it. Now, what I also want to show you is another type of surface. So instead of using a surface that's just stretched between edges or points, we also want to look at what if we're slumping our surface over a set of points that are resisting that downward force. So what we need to do is actually model a different type of surface in order to produce that effect. Now, the best way to do this really is actually to just create another couple of points. So I'm going to go ahead and make a copy of these components in Grasshopper. And then when I want to go back to Rhino and actually make some more points in Rhino. So I'll just select one of my points and copy it. Now if you use certain measurements for your points, you can obviously line them up accordingly. I'm just going to randomly place a couple so we get a sense of you know, one possible option. Now, because this surface has a bunch of points, we would actually need to model the surface in a totally different way, right? So this allows us to produce any surface with up to four points, 3 or 4 points basically. What we need is a surface that's kind of subdivided between these points. So this is pretty simple to do as well in Grasshopper. We'll just go to our mesh component, go to triangulation, and select Delaunay mesh. Okay. Oh, why is that not working? Okay, actually, let's do it a different way. Sorry about that. So we're actually going to model a polysurface in Rhino, and then we'll translate that into a mesh. So what I'm going to do is go into Rhino, and I'm going to produce a surface from 3 or 4 corner points between each of these points. So I'm going to create my own triangulation. Now, when you're doing this surface from 2 or 3 points, what's really important is you don't hit enter after the 3rd point. You want to go back to the first point and click it again. Now, I'll show you why. So if I click on 1, 2, 3, and then hit enter, so when I select this this surface, you can see the isocurves are collecting all at one point. If I click on this one, the isocurves are collecting at an edge, which basically means that if we were to try and mesh this surface, oops, we would get a result like that. When you model a surface that way in Rhino, oops, did I delete it? You've actually created a trimmed surface. So if I were to type untrim and click on that edge, you can see it actually created a surface where the same information is reflected across that edge, and then trimmed it. Now if I were to try and untrim one of these surfaces, you can see that I can't, because it's actually collected all the control points. So basically the point is, you need to always click the fourth point when you're making these surfaces. Okay. And I'm going to go ahead and join these all together. And then in Grasshopper, what I actually want to do is reference a poly surface this time. So instead of using my surface point and constructing that surface inside of Grasshopper, I'll just go to Parameters, Geometry, and instead of referencing the points, I'm going to reference the brep. So brep basically means poly surface. It stands for boundary representation, but all that it means is that you have a surface that is composed of a bunch of individual surfaces that are joined together. Okay. Now the other thing that we want to do, so if we were to plug this in and replace our surface, you can see if I turn my mesh edges on that it's still kind of subdividing by the same size of based on the slider that we set down here. So that's one important aspect. So our surface has been redefined. What we also want to do though is we want to give Grasshopper a couple of more points to kind of constrain that surface too. So again, because we're stretching it not just from 4 corner points, but we're also draping it over these 2 center points, we need to go ahead and set those points in Grasshopper. So I can do the same thing. I can copy this point component, and I'll just set it to these 2 interior points. And if I grab my anchor component, I can go ahead and plug those guys in as well. And now I'm also going to plug this back in, because if we end up moving these points, if we end up moving the slider, that'll cause the simulation to break. So I'll just unplug my move components and then plug back in the original points. Okay. And I believe that is everything set up. So I'm going to unpreview all my geometry that's not coming out of my solver. I will uncheck false, make sure my mesh is previewed, and hit the reset button. Okay, and you can see now what's being produced in our viewport is a similar surface to what we were looking at just a second ago between the 4 corner points, but we have these interior points as well. Now, if you wanted to, if what you did in your physical prototype was to have these points at different heights, what you would actually have to do is move the surface and move the control points. So if I turn my poly surface back on, I could go move edge, grab that edge, and I could move it down. Okay. So you can see I've given it some depth, right? As if these points were set lower. But I also need to make sure that these points are still on the surface. That's really important. Otherwise, Kangaroo won't know that those points are constrained. So I want to move the points as well down to the poly surface. Oh, why did that happen? Okay, so you just have to hit the reset button. I'm going to hide my poly surface. And then once again, if I were to turn on my solver, again, we would get a similar result, except with those points at a lower level. If I were to turn down the strength, I could see a much stronger drape, or turn down my gravity load. And finally, again, we can turn it off and turn up the subdivisions of our surface to get a finer resolution. Okay. Hit reset. Kind of wait for it to find its equilibrium. And there we go. So I could turn my solver off now, double click it to false. I'll select my mesh and I can go ahead and bake that. So if you're new to Grasshopper, what you want to do if you want to get geometry back out of Grasshopper and into Rhino is do something called bake it. So if I select my mesh component, right click on it and hit this button bake, you can see I have a little dialog that asks what layer I want to bake it to, and then I should actually have, oh, I guess my surface, or that layer I baked it to was off. Okay, and then I should have a piece of geometry in my actual viewport. And so you can see the kind of result of that simulation. And again, I do think it works better, especially with the complex simulations, to kind of crank up the subdivisions. Uh-oh, I think I just deleted a point. There we go. And by the way, we can still kind of play with the tensile properties. So we could bake that. Okay. And that's basically how you model the surface that you would want, or that you might use to create your drawings from. If you wanted to produce some geometry from this thing, remember that it's a mesh. So what you can do is actually go mesh to NURB. And that will turn that thing into a poly surface. And once you have a poly surface, you can kind of do all the same types of drawing operations and modeling operations as you would with any other type of geometry. We could do a make 2D. If we wanted to show it in axonometric, we could do we could give it a thickness. So if we wanted to show the thickness of the concrete shell, we could go offset mesh, give it some dimension. There we have a thickened shell. We could turn that into a NURBS surface. And then we could also take this geometry and do sections through it. And that would be how you would show kind of the curvature of that geometry based on how you set it up. And I think that's it for this tutorial.